Hello students, welcome to today's session. Today in this session, we will see the process of image processing. Okay, so the first step in image processing is of image acquisition. So now let's see what are the physical aspects. Okay, of image acquisition. So everything that we can look in this world is due to light. Okay, so let's see now what are the sources of light. Okay, so primary source, it is like sun. Okay, like it is our natural satellite that gives us lightness. Okay, secondary sources, it includes like moon, clouds. We can also get light from that. Okay, so secondary sources, they reflect the diffuse light from primary sources. Okay, like moon gets light from sun, then it gives light to earth. Okay, so again they rely on the primary source for lightness. Okay, these are secondary sources like moon and clouds. Now let's see how is our light. Okay, so light consists of several colors. Okay, like in rainbow we see pure colors. Okay, so this visible light is of 400 nanometer to 700 nanometer range of electromagnetic spectrum. Okay, see students, this is the violet color and this is the red color. Okay, so the three important points that we can use to explain any light is wavelength, amplitude, then frequency. Okay, so first of all, wavelength is distance between two successive wave. Okay, that is crest or trough. Okay, in any waveform, see this sinusoidal wave, so crest is the upper part. Okay, so the difference between two crest. Okay, crest means upper peaks, so it is called wavelength. Okay, then amplitude is the maximum distance between it travels from horizontal axis. Okay, so see how much it travels up from this side, this is called amplitude. Okay, frequency is the vibration of number of waves crossing through a point. Okay, if any we consider any point. Okay, and what is the number of waves that go through that point simultaneously, okay, at a single instant, that is called frequency. Okay students, this was all about the three basic terms that we use. Now let's consider a simple image model. Okay, see this image. In this image, it is a grayscale image. Okay, so one light source, it gives some light. Okay, so some light is incident on it, and it is reflected light that is seen by photo detector. Okay, then by process of digitization, sampling and quantization, we get a digital image. Okay, so the amount of light generated by light source, the and the nature of surface, amount of light captured by sensor, these are the factors that are required for any image model construction. Okay students, see this photo detector, digitization and digital image. Okay, see this. Now we will see the spatial coordinates. Okay, so x and y are the spatial coordinates. Okay, so any image function f of xy is equal to I of xy into r of xy. Okay, so I of xy is the incident component and r of xy is the reflected component. So image form is the product of both. Okay students, so this value of I, it can range from 0 to infinity, and reflected is always between 0 and 1. Okay, any decimal value it can be, but not more than 1. Then light emitted by an object at particular wavelength lambda can be defined as L of x comma y comma L is equal to sigma of x comma y comma L into L of y. So sigma e value is 0 for opaque object and perfect reflector it is 1. Okay, sigma value is the degree of reflection. So students, now let's see light intensity function. Okay, that is f of xy. So what is the value? Okay, And what is the nature, illumination and reflection component, what are its value, let's see. So illumination function, that is I of x comma y, and reflection function, that is r of x comma y, that are product, okay, which gives as product as light intensity function. And the value of this light intensity function, it ranges between 0 and infinity, okay. So remember this thing. Now see, if we consider any light source, okay, see this light source, it is emitting some light on object, okay, where the function of light source is L of x comma y comma lambda, okay. Then that function, that object reflects some image, that is I of x comma y comma lambda, okay. So there are two ways, okay, like we can get the image through eyes, okay, otherwise we can get through video camera, okay, so that is stored in computer. So image storage in human body is in brain and other is in computer, okay. So what is the similarity between eye and digital camera, that is we get the same image function, okay, reflected image function. Now let's see what are the color image fundamentals. Okay, so what are the color, like basic three colors are there: red, green, and blue. Okay, so color perceived, colors that human perceive in an object are determined by nature of light reflected by that object. See students, light color, like which are faint in means visibility, they absorb less light, whereas dark color, they absorb more light, so they are more widely visible. Okay, so visible light is composed of relatively narrow band of frequencies in a electromagnetic spectrum. Okay, so see, the frequency band is very less in visible range. Okay, we saw 400 nanometer to 700 nanometer. Okay, human color perceive is composition of different wavelength spectrum. Okay, then color of object is the reflectance in a limited range of visible spectrum that exhibits some shade of colors. Okay, so whichever the color reflectance is there, that is nothing but color of object. Okay, means after reflection, whichever visible spectrum is more large in value in terms of wavelength, that will be visible. Okay, so how to characterize light? Okay, let's see. So there are three basic quantities to describe the quality of chromatic light source. Okay, so first thing is gray level. Okay, gray level refers to scalar measure of intensity. Okay students, like it ranges from black to gray, then finally white. Okay, gray is the intermediate stage, and chromatic lights, it ranges between 400 nanometer to 700 nanometer. Okay, so radiance is what? It is a total amount of energy that flows from light source. Okay. Luminance is the amount of energy that is received from light source. Okay. Brightness is the subjective descriptor that is practically impossible to measure. Okay. See, brightness we cannot measure. Okay. It is just used for sake of description, like how it is more how the means how lightness content is more in that particular object image. Okay, so now students, we have studied the structure of eye. Okay, so in that eye, the cone, which is the color sensor of eyes. Okay, so let's see how that cone, it determines different colors. Okay, So there are three basic sensing categories, that is RGB. Okay, so maximum content is of R, that is 65%, green is 33, blue is lowest, that is 2%. Okay, so these three colors are called primary colors. Okay, red, green, blue. So students, we can see that which are primary colors: red, green, blue. Okay, and we can form different secondary colors like by mixing the primary colors. Okay, like see, red and green it is mixed, we get yellow. Then blue and red it is mixed, we get pink. Then green and blue if it is mixed, we get cyan color. Okay, and if we mix all the three colors, we get white. Okay, if we mix all red, green and blue, we get white color. Okay, but provided that it should be in equal and adequate amount. Okay, so now we will discuss about brightness, hue and saturation. Hue and saturation. Okay students, so let's see what is first brightness. Okay, as we see, so we discussed brightness is subjective description, okay, of light intensity. Okay, and it is not measurable, but we have some values of the brightness, limited values. Then hue is what? Hue is associated to dominating wavelength in mixture of light waves. Okay. So suppose if it is a mixture of rainbow light. Okay. So hue will be the light with highest wavelength. Okay. In rainbow color. Then saturation refers to relative purity or amount of white light mixed with hue. Okay. Means like how much white content is there in mixture of colors. Okay, and if we add hue and saturation together, it is called as chromaticity. So amount of red, green, blue form particular color, that is known as Tristolimus values. Okay, so see this value, small x is equal to capital X upon x plus y plus z. Okay, similarly and so on. So students, now we will study lightning system design. Okay. So on basis of the object surface, the imaging process may differ. Okay. So there are three different basic object surfaces types. Okay. So first is flat, other is curved, and the third is prismatic. Okay. Lightning plays very important role to obtain good quality images. Okay, see if there is more lightning, so the clarity level will be more. Okay, like it is like that, because of natural sunlight is not suitable for all imaging applications. Okay, see natural sunlight it may be means affecting like if we are shooting any image. Okay, so we have exposure of extensive natural sunlight, so our image will be not be that much clear. Okay, so choice of natural sunlight, it depends on which image processing application we are using. Okay, so students, the position of camera with respect to object, okay, plays a very vital role in image processing applications. Okay, so on basis of the image application, we can put the light source in front of object. Okay, or in the on the strips of object or in backside of object. Front lighting, light source and camera are placed above the object. Okay, structured lighting is used to project a pattern like strips on object. Okay, like we have some like obstacles. Okay, obstacle patterns, so that the only selective part of the light should fall on the object. Okay, then backlighting is used where we require very high contrast images. Okay, So see this positions of camera, object and light source. So direct lightning falls on the object and light source is also giving some like luminance to the object, so we get some image, okay, that is captured in camera. This is the example of backlighting, okay, also diffuse lighting. The diagram shows image formation model. Okay, so simplest camera used is called pinhole camera. The camera takes a huge amount of time for image formation. Okay, this camera was used in some olden times. Okay, so see students, the lens is you placed in front of the object. Okay, the image is formed on the image plane over here. Okay, now the place of image plane, it depends on the nature of lens used, convex lens or concave lens. Okay, it is based on that. So on basis of that, we can the image can be can be formed on the right of the lens or on the left of the lens. Okay. So students, that was for all for today. Okay, we will meet with new concepts on